Hey everyone, I wanted to make this video to discuss sequencing and how to go about sequencing different jobs in situations where you're asked to use one of three different approaches, right? So with sequencing, we typically are going to be looking at using either first come, first serve approach, which is what I'm going to do first here. This first example we see here, the FCFS means the first come, first serve, or first served. Okay. And then after that, I'm going to look at a sequencing approach, which use an earliest due date approach. And then I'll finish up by looking at a sequencing approach that uses what's called the shortest processing time approach. Okay? And with each of these approaches, my interest in looking at the three is to try and determine which one will result in the shortest amount of time to get product back to whoever requested it, whoever the customer is. So as I'm looking at these, just keep in mind, I'll be interested in figuring out what's the average past due date and what's the average flow time, right? So these last two columns here become our two columns of interest, okay? Because whichever has a lower past due date and possibly lower flow time typically would be the approach that we would want to use because it leads to a happier customer, okay? So let's look at this question here. So we have a situation where we have here 5 different customers A, B, D. I think this is already in order, okay? With the first come, first serve, you typically want to order your data by the time since the order was received, right? So whichever customer came first becomes the customer that you process first, okay? So you typically want to figure out for the strategy that you have, what column are you going to be sorting by? And in this case here, we're going to be sorting by the time since the order was received, okay? So my first step typically would be to highlight my whole entire data and do a sort, okay? So I will sort, let's get my sort function. Looks like it's missing. So I would sort by time since the order was received from largest to smallest, okay? And that then arranges my data side that I'm looking at the numbers here. The most current customer received last will be at the very bottom. The customer who came in first will be at the very top, okay? So now with this, I can figure out when do we start working on a specific job, when do we finish that specific job, okay? And we're typically going to assume that the very first job starts today, what we call day 0, okay? So starting with customer A's order, if we start processing today, it'll start at time 0, okay? And for the finish, I'll need to know how long does it take to process this job, right? So customer A's job is going to take us 25 days. So if we start today, we should finish in 0 plus 25 days, okay? So we finish the first job in 25 days. And as soon as we finish that first job, we're going to start the next job, okay? So the finish time for one job becomes the start time for the next job. So I know I'm going to be starting the next job on day 25 for customer B, okay? So keep that in mind. You're going to be dropping down that value to, let me just put in an arrow. So your finish time for the first job becomes the start time for the next job, okay? And your finish time for the second job becomes your start time plus your processing time, okay? So job B starts on day 25 and it's finished on day 41, okay? Now, these formula that I have here will stay the same, so you can drag this down to the bottom, okay? And you'll notice here that your finish time will become, if you put the right formula here, which is equal to 25, I didn't put the right formula in place, so that's why this didn't really calculate as it was supposed to. But this then becomes the finish time for one becomes the start time for the next, okay? And With that, now we have a rough idea of when we're going to start and finish the different jobs we have. Now I will use these finish times here and compare them with the due dates. I already have due date information over here. So if I copy this over, I can now, actually I don't need to copy this over. Let's calculate the actual days. Let's leave it in there. Let me backtrack. Let's go ahead and leave this in here. And let's calculate our past due dates here. Past due is the finish minus the due date. Okay. And once I've gotten those, I'm only interested in what days actually had a positive value. If I have a negative value like this -4, that is not past due, just change that to a 0. -3, that means that's not past due, and this is not past due, right? That shows that for this customer, we finished on day 77. We promised them that we deliver on day 80, so we're 3 days early. Okay. So down here, I'm going to calculate my average past due days, equal average, and average past due date for this specific business is going to be equal to 3.4 days. Okay. So that's one thing. And the very last thing that I'm interested in, what's the flow time? What's the total amount of time that every customer's order is going to spend in this business, right? So customer A, we received customer A's business 15 days ago, and we're going to finish it 25 days from today. So the total amount of time from when we receive the job to when we finish the job here is going to equal 15 days plus when we finish this, which is 25 days from today. Okay. So that first customer spends, his job spends a total of 40 days in this specific business. Okay. And you can repeat this for the next customer. The formula stays the same, so I'll drag this down. Okay. And I see here that it's the final customer whose job is going to spend the longest amount of time. It's going to spend 77 days before we're done with customer E's project. Okay. So at the bottom of this, I'll again calculate what's the average flow time. Equal average of these 5 values here. Okay. And my average flow time is 60 days for that specific customer, for this specific business. Okay. So that completes this first part of the question. And I was interested in how many days past due on average do we have? What's the average flow time for this specific business? We've done all that. We can now compare this with the second approach, which is the earliest due date approach. Okay. And I'll repeat the same thing over and over again, right? So with the earliest due date approach, I am interested in which customer requires their product back first, and we're going to be sorting by due date now. Okay, earliest due date, sort by due date. Okay, highlight your data, do another sort, and my sort here is going to be on the basis of due dates, and whichever is earliest, so the smallest to largest would be the approach that I'll use here to sort my data. Okay, so now as I'm looking at the due dates here, customer B goes first, then customer A, then customer D, then C, then E. Okay, so we're going to start with customer B today. So we start on day 0, and customer B's processing time is 16 days. So we are going to be finished with this customer in 0 plus 16 days. Okay, now that formula stays the same, so I can drag this down. Okay, now the end time for customer B becomes the start time for customer A. So customer A is going to start time here will be 16. Customer D's start time is going to be the finish time for customer A. Okay, so as soon as one job ends, you start the next job. Okay, so now we have our start and finish times. We can now figure out our past due and our flow times, because that's again our our two variables of interest here. So my due dates, I just copy this over and I calculate my past due as finish minus the due date. Okay, and you can drag that formula all the way to the bottom. Again, I'll be looking to see, do I have any negative values here? Anywhere with a negative gets changed to a 0. It's not past due. And I'll calculate the average past due date down here using the average function. And that gives us 3 days. Okay. The flow time, just like we did with the first table, the flow time equals the time since the order was received plus your finish time. Okay. So that gives us flow time for all the different customers. Again, the last customer is going to take 77 days before they get their product back. But let's calculate the average here and see how much of a difference we have. Okay, so here we have past due dates of 3 days on average, and our flow time average is 58.4 days. So that's better than what we had initially here. So this is a better option than what we had in the first table. Okay, so for right now, I know that this, if I was to be comparing two different approaches, the earliest due date approach with this data is better than the first come, first serve approach. Okay, but we have one last approach, and let's look at that, the shortest processing time approach. Same exact data, but now we're going to be using a shortest processing time approach. Okay, so that means that I'll be interested in sorting by this here column where we have our processing times. Okay, first step, again, always sort by what the question's asking. So we're going to sort by processing time here, from the shortest processing time to the longest processing time. So I go into data, sort, and I'm going to sort by processing time, smallest to largest, because we're looking for the shortest to largest processing time. Okay. Now, with that in place, I can now repeat the calculations we just did. First customer now is customer D. Let's have start time equal to 0 for customer D. And we're going to finish his job. It takes 10 days to process his job. So it's going to be 0 plus 10 days. I'll drag this formula down because it stays the same. Our start time for customer E equals the finish time for the previous customer. So as soon as we finish with D, we start customer E. This formula stays the same as well, so I'll drag it down. Okay. Then we go to calculating our past due dates and the flow time. So past due equals finish time minus the due date. Have a negative there. And so anything with a negative defaults to 0 because that means it's not past due. This is not past due, and that is not past due. Okay. Now let's get the average here. Full average. So my past due days is 14.6 days. And my flow time, this equals time since the order was received plus your finish time. Okay. So just like we did, you repeat the same process over. And here at the bottom, we're going to calculate our average flow time. I get 47.8 days. Okay. So now we've finished all 3 tables. I want to compare the numbers for the 3 tables here. Okay. With regards to past due dates, this shortest processing time here has 14 days. So that means that the average customer has to wait an extra 14 days beyond what was promised. That's way more than 3.4 days. One moment. And then that's also shorter than, that's also longer than the 3 days that we have on the second approach that we looked at, which was the earliest due date. Okay. So with regards to both flow time and past due dates, this approach here is the worst. Okay. We don't recommend going with this because those customers are going to wait the longest amount of time. The approach that works the best then would be the earliest due date. And that gives us a past due of only 3 days and the total flow time on average of around 58.4 days. Okay. So that's how you go about doing your sequencing. Okay. And you typically could be asked to do any one of these 3 different approaches. Okay. Always remember to start by looking at what column are you going to be sorting your data by. Okay. That makes a difference in how you calculate your numbers. Okay. All right. That's all I wanted to share for this. Stop right here.